Hey guys, welcome to College Made Simple, and in today's video, I'm going to teach you everything you need to know about dimensional analysis, which is divided into three parts. Number 1, what is dimensional analysis? Number 2, what are conversion factors? And number 3, how to set up a dimensional analysis equation to give us our desired unit. Then we'll conclude with a few practice questions and a brief walkthrough of their answers. So first, what is dimensional analysis? Dimensional analysis is taking a measurement in one unit and converting it into another measurement unit. This applies both within one measuring system, like going from feet to miles, both of which are in the imperial system, or from one measurement system to another, like going from meters, which is in the metric system, to feet, which is in the imperial system. But how do we convert one unit to another? To do this, we need to find the relationship between the two units we are converting, and this relationship is called the conversion factor. An example of a conversion factor that you're probably familiar with is the relationship between feet and inches. There are 12 inches in every foot. This is the conversion factor. Now this conversion factor can be written in two different ways. One is 12 over 1, which is every 12 inches is 1 foot, or 2, 1 over 12, that in every 1 foot there are 12 inches. When speaking to someone, they both mean the exact same thing, and there's going to be no difference between the two. But when setting up a dimensional analysis equation, you have to be very careful which of the two you use in order to attain your desired outcome. Let me show you what I mean with an example. Say I have a table that's 60 inches long, but I need to know how long it is in feet. How should we write this equation so that I get the desired outcome in feet? Before I answer that, recall that every number can be viewed as that number over 1. So in our case, 60 inches can be viewed as 60 inches over 1. Now with that in mind, the way to write the equation to give us our desired unit, which over here is feet, is to take whatever unit you have in the numerator, in our case inches, and place that unit in the denominator of the conversion factor fraction. So let's first set up the equation with just units, and we'll insert the numbers in afterwards. So over here, we would write inches, then open parentheses, and because we have inches in the numerator, we put inches on bottom of the conversion factor fraction and feet on top. Now let's insert the numbers. So we have 60 inches given to us from the question, and for the conversion factor, we know that every 1 foot is 12 inches. Once this is complete, we just plug this into the calculator. 60 open parentheses 1 divided by 12 close parentheses equals 5. So our answer is 5 feet. The brief reason behind how this works is when you have one unit and you divide that unit by the same unit, they both cancel out, leaving your answer in the remaining unit from the equation. So what we do in dimensional analysis is for whatever unit we want to cancel out, we place that same unit on the opposite side of the fraction. What I recommend to do to visualize this cancellation is to cross out any unit that's in both the numerator and the denominator. So here we would cross out both of the inches, the one on top and the one on bottom, leaving the answer in feet. Before we continue, there are some conversion factors that your professor will require you to memorize, but the rest are going to be provided to you by your professor and don't need to be memorized. Ask your professor which ones you're responsible to memorize, but typically the ones you need to memorize are 1 hour is 60 minutes, 1 minute is 60 seconds, there are 12 inches in a foot, 1 inch is 2.54 centimeters, and the metric prefixes. Here's a chart of the metric prefixes. Usually you just need to know from giga down to nano, but be sure to ask your professor what you're responsible to know. I suggest you make flashcards or go to Khan Academy, link in description, to practice the metric prefixes, but make sure you know them well, because it's very important, and you're going to use them a lot over the course of the semester. And when doing conversions with metric prefixes, here are 2 tips that I use. Number 1, always put the 1 by the prefix and the times 10 to whatever power by the base unit. For example, if you're converting between grams and milligrams, you would write 1 milligram, because the 1 goes by the prefix, over 10 to the power of negative 3 grams, because the 10 to whatever power goes by the base unit. And tip number 2 is to go from whatever prefix you have to the base unit, then to whatever other prefix you need to get to. For example, if you need to go from nanograms to kilograms, first go from nanograms to grams, then from grams to kilograms, so that you don't make any mistakes. It's important to note that most of the time you will need to do several conversions to get your desired unit, and the way to set up multiple conversions is exactly the same way as when setting up one. Whichever unit you want to cancel out, that unit in the conversion factor needs to go on the opposite end of the fraction so that it cancels out. Now let's do a couple of examples where you will need to do multiple conversions. Let's convert 6 feet to centimeters. So how are we going from feet to centimeters? The first thing to note is that we're going from the imperial system to the metric system. And one of the conversion factors that you should memorize is that 1 inch is 2.54 centimeters. And this will be our bridge between the two systems. Again, ask your professor what conversions you need to know, but this one is always good to know. So let's begin setting up the equation, but just with units, no numbers. So we have feet, which is what we start with. Then we have the conversion factor between inches and feet, and because we have feet in the numerator, to cancel it out, we put feet in the bottom of the conversion factor and inches on top. So the feet cancel out. Now we use the inches to centimeters conversion factor, and because we have inches on top in the previous conversion factor, here we put inches on bottom so that it cancels out. So we put centimeters on top and inches on bottom. Now the inches cancel out, leaving our answer in centimeters. Now let's insert the numbers. We have 6 feet from the question, and 12 inches for 1 foot, and 2.54 centimeters for every 1 inch. Now all that's left to do is run this through your calculator, which you can either enter in like this, or to speed things up, you don't need to enter in the parentheses, and whenever there's a 1, you can skip that as well, because 1 times anything is itself. Although when dealing with exponents outside the parentheses, keep the parentheses, because it gets confusing if you remove them. I'll show you what I mean later. But for here, you can simply enter 6 times 12 times 2.54, and you would get the same answer as if you were to put in all the parentheses and the ones. And the answer you should get is 182.88 centimeters. And once you factor in sig figs, your answer should be 200 centimeters. But if the question would have been to convert 6.00 feet to centimeters, then the answer would be in 3 sig figs, and it would be 183 centimeters. If you aren't yet fluent in sig figs, check out the video I made on sig figs, link in description. And if you are fluent, you would ask, wait a minute, shouldn't the answer be in 2 sig figs because of the 12? Or perhaps even in 1 sig fig because of the 1 in the conversion factor? That's a great question, and the answer is that conversion factors are never included in determining sig figs. The reason for this is because they are exact numbers, and exact numbers don't affect the number of sig figs. Here's one more example of regular multiple conversions, and then we'll do one with exponents, because that has something additional that we need to take into account. Let's convert 4,000 nanograms to kilograms. So the first thing we do is determine the steps to get from nano to kilo. And as I said before in tip number 2, when using prefixes, go to the base unit so that you don't get confused. So the equation with no numbers will look like this. Nanograms, open parentheses, grams on top, nanograms on bottom, close parentheses. Then open parentheses again, kilograms on top, and grams on bottom, close parentheses. Now the nanograms and grams both cancel out, leaving us with kilograms. Now let's plug in the numbers, and like I said in tip number 1, for the metric prefix conversions, put a 1 by the prefix and the times 10 to whatever power by the base unit. So we have 4,000 nanograms times 10 to the power of negative 9 grams, the base unit, over 1 nanogram, the metric prefix, and 1 kilogram, the metric prefix, divided by 10 to the power of 3 grams, the base unit. Next, we'll plug it into the calculator, and again, when putting it into the calculator, you can either enter everything or skip the ones and the parentheses, and just enter 4,000 times 10 to the power of negative 9 divided by 10 to the power of 3, which should give you 4e negative 9. The e means times 10 to the power of, so our answer is 4 times 10 to the power of negative 9 kilograms. Now for the conversion with exponents, let's convert 500 cubic centimeters to cubic feet. And again, the first thing we need to do is determine how we're going from centimeters to feet. And that would be centimeters to inches, and then inches to feet. So our equation without numbers will look like this: centimeters cubed, open parentheses, inches on top and centimeters on bottom, then open parentheses, feet on top and inches on the bottom. Now let's plug in the numbers. So we have 500 cubic centimeters, and then 1 inch over 2.54 centimeters, and 1 foot over 12 inches. But as you may have noticed, we have a problem. In order for the units to cancel out, there needs to be the same unit in the numerator and denominator. But we have cubic centimeters in the numerator and just plain centimeters in the denominator. To fix this, we need to cube the entire first parentheses. And when we do that, all the numbers as well as their units in the parentheses get cubed. So the 1 gets cubed, the inches get cubed, the 2.54 gets cubed, and the centimeters gets cubed. This is known as the distributive property of exponents. But for now, let's leave the cubed outside the parentheses. You'll see why when we start plugging this into the calculator. But now the inches don't cancel out. So we need to cube the second parentheses as well. So now, the centimeters cubed and the inches cubed both cancel out, leaving us with feet cubed, which if you look back at the question is our desired unit, the one we need to convert to. So let's plug everything into the calculator. 500 cubic centimeters, open parentheses, 1 divided by 2.54, close parentheses, cubed, open parentheses, 1 divided by 12, close parentheses, cubed again, and we should get 0.01765. And the answer with the correct number of sig figs is 0.02 cubic feet. And for those that don't want to enter everything into the calculator, in this case, you would just enter 500 divided by 2.54 cubed divided by 12 cubed. And you would skip the ones because 1 cubed is still 1. Again, do as you please, but I advise to just plug everything into the calculator to prevent mistakes. Now here are some practice questions. I'm going to start off with single-step questions and progressively build up to 3 or 4 steps. And once you get the hang of what unit to place on top and on bottom of the conversion factor, everything is going to be smooth like butter. And remember, the more you practice, the easier it gets. So for number 1, convert 3.62 centimeters to meters. Number 2, convert 749 meters to inches. Number 3, convert 504 pounds to kilograms. Number 4, convert 1,826 cubic feet to cubic kilometers. And number 5, convert 55 miles per hour to centimeters per second. I recommend you pause the video and try to solve them on your own, and then come back and see how you did. Now for the answers. For number 1, your equation should look like this: 3.62 centimeters, open parentheses, 10 to the power of negative 2 meters on top, divided by 1 centimeter on bottom, close parentheses, which plugged into the calculator is 3.62 times 10 to the power of negative 2, which equals 0.0362 meters. One last thing to note. Some professors may require you to give your answer in scientific notation, which for this answer would be 3.62 times 10 to the power of negative 2 meters. If you don't know how to transform a number from decimal notation to scientific notation, check out the video I made on scientific notation, link in the description. Next, for number 2, the equation should look like this: 749 meters, open parentheses, 1 centimeter on top, 10 to the power of negative 2 meters on bottom, close parentheses, open parentheses, 1 inch on top, divided by 2.54 centimeters on bottom, close parentheses. Now let's plug this into the calculator. We have 749 divided by 10 to the power of negative 2 divided by 2.54, which equals 29,500 inches. For number 3, the equation should look like this: 504 pounds, open parentheses, 453.59 grams on top, and 1 pound on bottom, close parentheses. This conversion factor of grams to pounds should be provided to you by your professor. Then open parentheses, 1 kilogram on top, divided by 10 to the power of 3 grams, close parentheses, and plugged into the calculator, 504 times 453.59 divided by 10 to the power of 3 equals 229 kilograms. For number 4, Your equation should look like this: 1,826 cubic feet, open parentheses, 12 inches on top, 1 foot on bottom, close parentheses, cubed, open parentheses, 2.54 centimeters on top, 1 inches on bottom, close parentheses, cubed, open parentheses, 10 to the power of negative 2 meters on top, divided by 1 centimeter, close parentheses, cubed, open parentheses, 1 kilometer on top, divided by 10 to the power of 3 meters on bottom, close parentheses, cubed. Plug this the same way into the calculator, and this equals 5.171 times 10 to the power of negative 8. Again, E means times 10 to the power of. Another way you could have written this equation is 1,826 cubic feet, open parentheses, 1 meter cubed on top, divided by 35.315 cubic feet on bottom, close parentheses. This conversion factor of cubic meters to cubic feet should also be provided to you by your professor. Then, open parentheses, 1 kilometer on top, divided by 10 to the power of 3 meters on bottom, close parentheses, cube it, which would give you the same answer as before, 5.171 times 10 to the power of negative 8. And for number 5, this is where we don't just cancel out the unit on top, but also the one on bottom. But again, it's the same idea. Put the unit we want to cancel on the opposite side, and they'll cancel out. So the equation looks like this: 55 miles per hour, open parentheses, 5,280 feet over 1 mile, close parentheses, open parentheses, 12 inches on top, 1 foot on bottom, close parentheses, open parentheses, 2.54 centimeters on top and 1 inch on bottom, close parentheses. This part takes care of the miles, which are now in centimeters, but we also need the hours to be in seconds. So we do open parentheses 1 hour over 60 minutes, close parentheses. This way the hours cancel out. Then open parentheses 1 minute over 60 seconds, close parentheses. This way the minutes cancel out. So now we also have seconds on bottom. Plug this into the calculator. 55 times 5,280 times 12 times 2.54 divided by 60 equals 2,458.72 centimeters per second. But with the correct number of sig figs, that would be 2,500 centimeters per second. Thank you so much for watching. If you enjoyed the video and found it helpful, please consider hitting the like and subscribe buttons. If you have any questions or tips for how I can make the videos better, please let me know in the comment section down below. Have a great day, keep learning, and peace out.